So in this example, we have the blue function and the red function, which is piecewise, and we need to evaluate the following. Two items to evaluate. Part A, we want to evaluate the limit of f plus 5g. And this is when x approaches negative 2. In part B, we want to evaluate the limit of the product when x approaches positive 2. Okay, I'll give you a minute or two to try to do it on your own before I'll show you my solution. So we got one form for A, but I'm not sure. Did I hear a clear answer for number 3? Negative 9. Okay. I think I got something else, but let me see. Okay, let's start with A. What is the limit here? We start with, I like to rewrite. So f of x plus 5g. And the first step will be following the procedure we just, or the laws that we just learned. I'm going to use the sum property. Okay, so by the sum property, it will be the limit of f of x when x approaches negative 2 plus the limit of 5 times g of x, like so, when x approaches negative 2. So use the sum law. Okay. The next step is to use the constant multiplier and then simply substitute. So yank out the 5 out of the limit. So this was the constant multiplier. And now we can evaluate. So what is f of x when x equals negative 2? Going back to our graph, where there, f is the blue. We have a point of discontinuity, but we have a plug-in. So looks like it's y equals 2, so it will be simply 2. I'm sorry, the limit is 1. I'll take it back. See, the limit is 1 as we approach from the left and approach from the right. So you can see that it's easy to fall into this trap, evaluating the function rather than the limit. Okay. I heard somebody in the crowd said, oh, I did the same thing. Yeah, so it's 1, not 2, and then let's look at g when x equals negative 2. Looks like it's 0. We have the 5-minute warning, so we have 1 here plus 5 times 0. So indeed it's equals 1. The answer is 1. Okay, let's do part B. Again, part B I believe is a product, right? So we're looking at the limit of f times g when x approaches positive 2. So first, I think I'm out of the paper, so go back here, apply the product rule, so it will be the limit of f when x approaches 2 times the limit of g when x approaches 2. Okay, so let's move the paper to the side. Let's look back here and look at it side by side. So what is the limit of f when x approaches 2? Looks like it's 3, isn't it? Yes. What is the limit of g when x approaches 2? Okay, somebody from Mariam. I'm sorry? It doesn't exist precisely because you approach from the left, it's -3. You approach from the right, it's -1. They have to equal each other. So we have 3 times down dne. The limit of g when x approaches 2 does not exist. So the answer will be simply does not exist. Okay?